good position?
I believe so.
You feel can you see?
The screen or for... I can't see it, but I think it is.
No, the other way. Like that. Okay. Make me look good. Thank you. All right, so we will be recording, okay? Don't shut anyone unless you want to be picture with me. But if you say something, it will be okay. Everyone is okay? Only okay, then I do it.
Can't really do that.
Are we okay?
Okay.
Okay, all right. Go. Already on?
Yeah.
Okay. All right, so this is part 2, all right? So for task 3 and 4. Okay. Now let's go back to take a look at what did we do in task 3 and 4, right? So task 3 on page 77. So what did we do? We took 10 ml of glacial acetic acid, which is 17.5 molar in concentration, and then we dilute to 250 ml with water. Okay, so that's what we did. So that's the M1V1. Alright, so just write it. Alright, so we have 17.5 molar, and we took 10.00 milliliter, and then we dilute it to 250 milliliter, and then what concentration was that, right? So we divide by 250, and of course that is equal to, someone calculator, what we got? On 7, all right, so someone say 0.7. Agree? So it's 0.7 molar. So yes, that's right. I have it. So it's already in the worksheet. So it's 0.7. I used to just write 0.7, but really we should follow the sig-fig. So it's 3 sig-fig in here. So I already changed it and make it good for you. So I add 20 in here. I know before student and then just return back to me is in 0.7. That's not okay. It's not meant, I try to fool you guys, but you need to think a little, all right? So all this is a help. By no means is all perfect and ready. So it's 0.7. Are we good? Now, so we did that and we call it A, right? We call it A. We call it A. And what did we do? We take out 10 ml of A and dilute it to 100 ml, yeah? And then we call this is B. Remember we learned the alphabet? So yeah, So 10 mil to 100 mil, what does that mean? 10 mil to 100 mil. What is that factor? What's the factor of 10 and 100? Factor of what? 10. Factor of 10. So we increase the volume by 10, and therefore the concentration will decrease by 10. Yes or no? And so on and so on. Remember, we did the English A, B, C, D, E. That's what happened. Now this time I already make it good. Yes, don't drop the sig fig. We cannot drop the sig fig, right? Okay. Now, any volunteer of your own data, guys? What's your pH?
I got 2.57. Right.
Anyone? Two point five six. Maybe one more. A little bit different than this. Anyone? No? 2.48. Okay? And so on and so on. So all these are your data, yes? And so would be the BCDE. I'm not going to, this is again sample, right? Not yours, not for you to use. Sample. Okay, what about the theoretical pH? How do we do? What do we do? So we go back to the equilibrium expression we talked about earlier. So here's the Ka. And by the way, I think I went too fast earlier when I flipped the page with you guys. But I did do that on yesterday. So such as on page 71, so we use the acetic acid and we provide you the pKa is 4.74 and the Ka is 1.8 times 10 to minus 5. Everyone see that? So we look at this equilibrium expression. Do we know Ka? Do we know the Ka? Yes. So Ka is equal to 1.8 times 10 to minus 5. That is because it's acetic acid. Okay, do we know this guy? What is this? This is your what? Weak acid, yes? What is that? What is that? Is that the weak acid? Acetic acid is your weak acid. So this time is not A, it's AC. AC stands for acetic acid. So this one is equal to what? 0.7. I just dropped the sig fig for now for quick writing. Okay, do we know the proton? Do we know this? Yes or no? No. So that's the pH we are looking for. So this one, we don't know. So this one we don't know. What about this conjugate base? Do we know yet? Do we know the conjugate base? I don't think so. So this one we don't know either. So we have two unknowns. Well, that will be trouble in one equation with two unknowns, right? So we look for good news. Any good news? Well, you look at this equation. It's 1, 1, 1. So what that means is this and that will be the same. So these two are the same. So that's good news. Even though we don't know these two, but we know they are equal, that's something. That's something. So therefore, if I write it this way, it will be x and x, and this one is 0.7. Now, is this true? Is this true? What did we say in here? Equilibrium, right? Remember? I emphasize it's equilibrium. So therefore, is 0.700 the equilibrium? Is that the equilibrium? We did not say, we didn't say. Is it the equilibrium concentration? Or is it not? Yes or no? The answer is not equilibrium concentration. It's your initial concentration. So 0.7, unfortunately, is not the equilibrium. It's your initial. How can I go from initial to equilibrium? You have to minus the x. This x and that x is the same thing. So we have to minus x. Now we are going to solve the equation, right? So if now perhaps now I can erase this one. Yeah. So we can solve the x, of course, but we can do a little shortcut and say this x in compared to 0.7 is small, only a little bit, and so it's not significant, and it's like 0 compared to this one. We can do that little assumption, and then now we can easier, then we can do that, and then we can square root, and then we can get the x. Okay? Now, can someone tell me what this number is? 1.8 times 10 to minus 5 times 0.7, and you square root it. Okay, so someone got the answer is 3.5496. Okay. 3.5496 and so on times 10 to minus 3, I believe. That is your X. Well, what is X? X is the proton concentration. Don't close the. So that's your X. Proton concentration. But we want to do the pH, so log of that number n times minus 1, so it's equal to 2.4449, so I just run it to 2.45. So that's your pH. Everyone? Well, so the 4.5. So here's the striking and very important 2.45 by calculations. So I keep 2 sig fig in the mantissa. I could have kept more, but I cannot. That is because our Ka is only 2 sig fig. So I only did 2 sig fig. That's fine. So it's 2.45. That is purely, completely by calculations. That means I could have done it yesterday, I could have done it 100 years ago, or tomorrow, or anywhere, anything. This is purely by calculations. Yes? While I had cut a little corner in here, of course. Otherwise, I could have do the real math of solving the X. But look at your data, guys. Look at this one. 2.48, 2.45, 2.5 something, a little bit above. Not too bad to predict your experimental answer. You see what I mean? That is very striking. That is very important. How strong and how close to our calculations and compared to your actual experiment. Are we good? That is very important. Okay, well, you can keep on going and do the same for the rest. And so would be your data in here. But let me caution you, by the time you go to solution D and E, what that means is the concentration in here is 0.3 and minus X. At that point in time, your X is not small in compared to this number. This is a small number, we know that. 0, 0, 0. And so this is not that small in compared to here. So you cannot ignore the X. And so you will do the real math to solve X. Yeah? So that means, okay. And then move over. So X squared this will go in, and this one. So you're going to distribute it, and then that will be your A, and then you get your B and C, and you will do your quadratic equation. Okay? So you need to, and you must do quadratic for D and E. While C is semi, maybe, and we just cut corner. That's okay. I mean, but D and E you cannot. Okay? Now, what about the percent ionization? So the percent ionization will be 10 to minus of your pH. So in this case, for example, would be 2.57 negative, 10 to negative 2.57 divided by 0.7, which is the initial concentration, and times the 100. So you get the percent. And the theoretical would be 10 to negative 2.45 and divide by 0.7 and times 100. Are we good? So that is task 3. So the challenge would be D and E, you need to do a quadratic equation first. Okay, task 4. So task 4, what is task 4? So let's recall task 4 on page 78. So we say we took out 50 mil of A, all right? So we took out 50 mil of A. So we have our solution A, which is 0.7. I just dropped a citric for now. 0.7 molar, yeah. And then we take out 15 mil of that. Yeah. Now what do we need to do? So if you read and follow the instruction, we want to neutralize half of the solution. So we want to neutralize half of the solution. What do we mean? Well, let's write out the equation. When we have the acetic acid and we neutralize with the sodium hydroxide, yes? And of course the sodium is the spectator ion. And then we get this. What do we get? What do we get? It will be what? Water. Yeah? We get water. That's neutralization. What else we get? Conjugate base. We also get conjugate base. So when we neutralize, we acid with sodium hydroxide, strong base. When we neutralize this two, we get water, that's neutralization. And then we also get conjugate base. Now, because we do it by half, so half will remain as acid. Half will be in weak acid, And half will become what? Conjugate base. So half will be our conjugate base. So that's what we want. So how do we do? How can we do? Well, let's take a look. So we have 0.7 molar and then 15 mil. So volume times concentration, we get the mole, we get 35 millimole. So we have 35 millimole. And we want to slash by half. So slash by half, that is 17.5 millimole. And since our sodium hydroxide is 1 molar, so our sodium hydroxide is 1 molar, and so therefore we will add 17.5 of sodium hydroxide. So we will add 17.5 milliliter of sodium hydroxide, which is 1 molar. So now we neutralize this weak acid by half. But now the total volume is 67.5 milliliter. Yeah? Well, what's the concentration? Well, when we do this, well, let's follow the English alphabet. So we call this as solution F, right? Remember? Okay. So now we have 17.5 millimole of the weak acid and divide by 67.5 milliliter, and the milli and milli cancel. Now we get, what's the concentration? .259 something, right? 0.259, excuse me. Well, I know. I have it for you. I wrote it down for you. Yeah? Now, that is solution F. And what you did further was what? You took out 20 mil and dilute to 100 mil. Yeah? So 20 mil dilute to 100 mil, then F and G, right? So F and G. So 20 to 100, what is the factor? What's the factor? 5. Factor of 5, so therefore the concentration of G will be diluted by 5. Yes or no? And then we keep on learning the alphabet. H will be G divided by 5. I know, students come back. I'm so confused. What's G divided by 5? I don't know what's G divided. Cannot. But I hope you know that number divided by 5. Yeah? What about I? That will be H divided by 5. Now, what about this one? What is this? That is the conjugate base. Now, you look at here, the conjugate base. So when we neutralize weak acid, we get water, and we also get conjugate base. And because we make it smart and decided in this way is by half. The good thing about half is whatever this will be equal to whatever that, right? That's half. I mean that's the half. That's the the implication. Half, both are the same. So that means whatever your weak acid, it will be whatever the conjugate base. Whatever the conjugate base will be whatever. So therefore, I just say this two will be the same. Again, in the last time, please don't break my heart. I know students just copy and paste like this. Don't say same, just like what I did in here. Tell me the number, please. Everyone? Okay? I know, I just copy you. Don't do that. Okay, well, this one would be your own data, which nothing we can do. I know one group, it was like, one group was 5. Is it 5 in that group, or maybe the other center? Anyway, so that's your data. Okay. Now what about here? What is this guy? That's your conjugate base. That is this number, yeah? What about this one? That's your weak acid. That's this number. This number over that number is what? 1. They all 1, yes? Well, finally, you got this box or column to work on. So you are going to calculate this one using your data. I give you the hint, use the HH equation, Henderson-Hasselbalch equation. So this one is for your challenge. You need to come up by your own. Any questions? All good? So in short, I pretty much went over this one for sure you need to, and there's 2 questions for sure you need to by yourself, and then you need to have the graph, title and so on, and your data. All good? Now only I just go over the worksheet, look at the syllabus, follow whatever we ask you there. It may be more. This is only part of, not the whole thing. Okay?